Size returns the size of the vector. Get returns an element in that vector. Sets an element of the vector. Fills the vector. ToString produces a string representation of the vector, which you would probably use in debugging a lot, right? My vector and matrix classes all have ToString methods. Use them copiously to make sure your stuff's working the way you expect. Okay. Squared magnitude. Why don't I just compute magnitude? Because sometimes squared magnitude is good enough, and that saves me doing a square root, which happens to be a slow operation. You can always take the square root of the squared magnitude to get the magnitude. Okay, you can copy vectors. This actually makes a deep copy, right? Yeah. You can add two vectors. See, it's just a for loop, and it just adds the elements together. You can scale vectors. See, it just takes the scalar and multiplies it by every element. Add scaled basically takes this vector, scales it by that scalar, and adds it to this vector. That's a darn useful one. Do you see that if you wanted to, oh, there's dot product. There's the one you really need. Takes two vectors, dot products them. Do you see that if you wanted to, you could add methods to this vector class and it wouldn't be that hard? You just add a for loop and you just kind of look at one of the examples and kind of do what it does. Okay, this class now belongs to you. If there's a bug in it, it's your problem. And if you need a function that's not there, add it. Don't get in this my hands are tied mode where I'd like to use your vector class, but it doesn't do dot product. Well, it does do dot product. It doesn't do outer product. Well, I don't care. Add outer product. This is your class now. Okay. Let's look at the matrix class. I have a matrix class. The main thing a matrix class has in it is this data, which is an array list of doubles. I could have used my own vec class, but I didn't for historical reasons. So I apologize for that. Yes?
So in the C++ version, that does use a vector of x.
Yes.
And
there are actually efficiency reasons why I didn't do that. It was thought through. Sorry, carry on.
one of the issues I had was figuring out when to use the matrix and when to use the vec.
Okay.
So should I only use the matrix class and just make one row of matrices as vectors? Or should I use a vec if I know?
So should is kind of an interesting term here. I really want you to do whatever the heck you want. The reason I say that is because, you know, it's really just math. And if you do the math right, it'll work. In the end, implementation details are for software engineers, and this isn't a software engineering class, and I don't give a darn. Having said that, I use the matrix class to load my data sets because it has this convenient load arf function, which loads data in the format that we happen to have. So that gives me matrices. Then I'm going to use the row method, which returns a row from this matrix. There it is, in vec format. And basically, I'm going to do everything else with vecs thereafter. So kind of the only purpose for the existence of this matrix class is so you can load a data set. And thereafter, I like to work with vecs. I think vectors are simple and easy to work with. And then you don't have to worry about all this matrix garbage, and your life will be easy. Now, having said that, if you like the matrix class, by all means, use it. If you would prefer to just work with your own data structures and throw out my vector class, please do that. Don't feel constrained by this. You don't have to do it. If you just want to use double arrays, great. I'm just trying to be helpful here. Don't let me constrain you. So I like my vec class a lot. I use it for everything. There's the answer. Ah, yes. You will pretty much have to marshal all your numbers into a matrix just to call pseudo-inverse and then marshal them back into whatever you want them to be in. Just because you don't want to write this function. Let me prove it to you. Let's see. Pseudo-inverse calls singular value decomposition helper, which looks like this, and that, and that, and that, Still going. Oh, it ends right there. Okay. I swiped that from numerical recipes in C and then ported it to Java. So it's not even my code, but that just works. So for that moment, you will have to use matrices. Yes, it's a pain to shuttle data back and forth. You have to write loops, maybe 2 for loops, one that goes across rows, one that goes across columns, set all the elements. Can you handle that? That shouldn't be hard, so that's it. Okay. What else do we have here? Let's look at it in graphical format, because some people are more comfortable with that. That's still list format.
Oh, we have to write a build script to build the code?
There's already a build script here. Let's look at that. Java C star.java. That's basically what you do to compile anything. So that is not much of a build script. The reason I have a build script is when you submit your code, what will happen is it'll look through your code for a build.bash file, and it will execute it. Now, it should only build your code, not run it, and it should also not execute a secret Trojan horse that you've stuck in there to try and take over my server machine. Yes, I know you're smart people and you can do that. Please don't. So the server will build your code, and if it all compiles, then it will accept it, and then I'll go look at it. The reason I did this is because I get so tired of code that doesn't even compile. I don't want to see that. So it'll spit it back out at you if your code doesn't compile, and then you'll know you have to fix something and resubmit. Is that fair? If there's a cross-platform issue, you might encounter that during submission time, so plan accordingly. If there's anything you don't know how to resolve, send me an email and I can work through those. This is not a operating systems class, so if it works for you on Windows and doesn't work for me on Linux, I'll work with you. It's kind of my problem, but at first it'll probably spit it back out at you, and you might have to exchange an email with me. If it's 2 minutes until the deadline, just submit it, send me an email, and tell me the problem, and I'll try to deal with it. Is that fair? Yeah, Kate is a text editor it's the one that comes with KDE. I used KDE long ago and I liked it, and now I'm kind of stuck on it. My window manager is actually XFCE, because I like minimal better than KDE. Use whatever you like. XFCE. This is an installation of Xubuntu, Xubuntu. I'm not trying to evangelize that. I'm just answering a question, but there it is. Okay. What have I not gone through in this starter kit? There's a file named json.java. This is for serializing your stuff. I think you don't need to use it in this class. Sorry for including it in the starter kit. If you want it, there's an example of how to use it. Yes, I have a doohickey class and with a bunch of member variables so it can marshal them all and then unmarshal them. Okay. And what else? There's a main file. If you look at main, you'll see what it does. It calls test learner. Test learner tests a learning algorithm with 3 different data sets. These are 3 data sets I've included for you just so you can see it work. Takes your data, it loads them from an ARF file. It trains the learner. This, by the way, is the world's stupidest learner. It splits the data up into test features, counts the number of misclassifications, and spits out the answer. You want to see it run? I'm sure you've already seen it. Bash. There, I've compiled it. Java main. I run it, and it reports the number of misclassifications by this learning algorithm. Let's look at the baseline learning algorithm just so you can see how it works. This is baseline. Here's how it trains. I compute the average or the column mean of all the columns, and when I make a prediction, I predict the mean. That's how it works. Would you call that learning? That's about the dumbest learner you can actually ever write. Why is that useful? Because if you write a learning algorithm and it doesn't beat this one, you know your learning algorithm stinks even more. So it's really good to have a baseline to compare against, because if your learning algorithm beats this one, then you know, hey, some learning is occurring. This is kind of the epitome of not learning at all, is just computing the column means. Therefore, you should expect any reasonable learning algorithm to beat baseline. Therefore, I provided baseline so your algorithm can beat it. It's a straw man for attacking and destroying is what baseline is all about. Okay. Ask me questions. Any coding issues that have come up, and can I help you address them?
Oh, in C++, why did you read, for the predict constant, why did you return constant reference?
Okay. Let's see. Vector runs it. 2018. Web. 2018. A1 starter C++. Zip. CDP. Source. Okay, supervised.h. I think the question is, why does this predict method return a constant reference to a vec? Right? Okay. Seemed like a good idea at the time. Here's how I imagine doing it. Well, let's look at this baseline class as an example. Baseline.h, baseline.cpp. Okay. Look at the header file here, and you'll see how there's a vector here named mode. And the mode is basically the most common value in all the columns, or the average of all the columns. Now, if we look at the predict method here, the way I make predictions is I just return mode, which is my that member variable that I computed, right? I really wouldn't want the caller getting a prediction and then messing with the values in it and then mucking up my model that I use to make predictions. So at least you'll see that it makes sense for the baseline class to make it constant, since I'm actually returning a vector that's stored inside of my object. Does that make sense? Likewise, when you end up coding a neural network, you'll have some kind of internal buffer that stores the activations of your values, the values you compute, and you'll want to return that without having to make a deep copy, just because it's darn efficient. Now, the caller will probably want to make their own copy, and because the vector class has a copy method, it doesn't cost anything to return the internal one. So this is the really efficient way of getting the answer back as fast as possible. And if the caller wants a vector that they can mess with, they can make a deep copy. That was my rationale behind it.
So if the return of predict, we cannot change the element in the vector.
The caller cannot change what you return, but the caller can certainly make a copy and then change their copy. And that's more efficient than having the predict method always make a copy and return it, because a lot of times the caller won't need to change it. And so we might as well do it the fast way, right? That was my thinking. Okay.